We're getting ready to start the second largest topic in Calculus 1, and that is antiderivatives and integrals. And so what we've been doing is taking the derivative, and what we're going to be doing is doing the reverse of that. Given the derivative, we're going to find the original function, and known as the antiderivative. Integration and antiderivatives use the same rules. So, what is the theorem for an antiderivative? It says that if f prime of x is equal to f of x, then f of x plus c is the general antiderivative of f of x, where c is an arbitrary constant. Now, I'm going to explain that a little bit more as we work through some of the problems. So you'll hear me refer back to this idea right here many times today. The general antiderivative of an x to the n is you take the x and you raise it by 1 and you put it over that same power. So say this was x to the third. Well, what this is saying to do is to say it's x to the third plus 1 over 3 plus 1. So in other words, it's x to the fourth over 4. Now, we'll go into that in more detail as we start to work through these antiderivatives. So what I'm going to ask you to do, first of all, is find the antiderivative of a constant. The antiderivative of this constant number would be f of x is equal to 4x plus c. Think about it this way. If you were going to go backwards, and I ask you to take the derivative of this, you would tell me that the derivative of big F would be big F prime, and then you would bring this out front and you'd tell me it was 4. Take the derivative of the constant is 0. So you can check every single one of your antiderivatives by taking the derivative of it. Let's do another one then. So we're going to find the antiderivative of x. Well, you raise it by 1. The exponent there is 1. You raise it by 1, and you put it over that same exponent. While that looks funny, really all it says is 1/2 x squared plus c. Here's my check. I'm going to check to make sure I did it right. If I take the derivative of the big F, okay, I'd bring the 2 out front. 2 times 1/2 is 1. X, lower it by 1, 1. Take the derivative of the c, which is just 0. So notice how I get back to where I started. So this is checked out. It does work. The antiderivative is correct. The next one, so that was my solution. The next one is the same thing. The rule is raise it by 1 and put it over that same power. Add the plus c. I'm going to check this. When I check it, here, I'll rewrite this first. So it's 1/4 x to the fourth plus c. This is my solution. When I take the derivative of this, bring that 4 out front, I get x, lower it by 1/3, take the derivative of any constant, I get 0. So it does check out. Let me go back and address this whole constant thing. The reason why we have to name it c is because there's so many different solutions. If I was to take the derivative of this function right here, f of x equals 4x plus 5, and I took this derivative, the derivative would be 4. If I was to take the derivative of this function, 4x plus 6, the derivative of it is 4. So that's why when we take the antiderivative, we've got to add this plus c, because c is an arbitrary constant. We don't know what's being added on. We don't know what the constant is on our original functions unless we're given more information about it. So we always are going to have to remember that plus c. Do not forget the plus c, otherwise it will be incorrect. I'm going to continue to find antiderivatives and check them. So we're going to take the antiderivative of this f of x. So the antiderivative is 5x to the third over 3. plus c. Always remember our plus c. So we get 5/3 x to the third plus c. This is our solution. Now, I am going to do a check every time. So if I check this antiderivative and I take the derivative of this, I bring the 3 out front, it gives me 5, and I lower it by 1, which should give me a 2. Notice how I get back to where I started. The derivative of the constant is 0. The next one, I'm going to raise it by 1, put it over that power, put plus c. Don't leave your answer like this. Let's clean it up a bit. This says a negative 3. This says put it on the bottom, plus c. Now, if I'm going to do a check on this one, I really have negative 3x to the negative first plus c. And so when I take its derivative to check this other part, I get that I found a mistake. That happens. So I get 3x to the negative second, and oh, never mind, I didn't make a mistake. Sometimes I'm crazy. You guys know that. Okay, the derivative of c is just 0 then. So it did work out because I got 3 over x squared, or 3x to the negative second. The next one, the last one on this page, find the antiderivative. We have 5x to the fourth over 4 plus 3x to the third over 3 plus 7x to the second over 2 minus 3x plus c. I know I went through that very quickly, but I'm using the same rule every time. Keep the constant, write down your x, raise it by 1, raise your power by 1, put it over that same power. Plus, keep your constant, write your x, raise it by 1, put it over that same power. Keep your constant, raise it by 1, raise your power by 1, put it over the same power. Minus 3, there is no power, it's x to 0, so we are putting it x to the first over 1, and we're done. You can clean this up as well by saying this is 5/4 x to the fourth plus x to the third plus 7/2 x to the second minus 3x plus c. You can do a check. The check ends up being, bring the 4 out front, 5x to the third plus, bring the 3 out front, 3x squared plus, bring the 2 out front, 7x minus 3, and we're done. Continuing on with more antiderivatives, I'm just giving you lots of different examples. So this one now has some fractions in it. We're still going to use the same rules. So we're going to say 3x to the raise it by 1 gives me 1/2. Put it over that new power. Plus 5x to the raise it by 1, that gives me 5/3. Put it over that new power. Plus c. We're not going to leave our answer like this. 3 divided by 1/2 is really 3 times 2, which is 6. X to the 1/2 plus 5 divided by 5/3. 5 over 1 times 3/5 gives me a 3. X to the 5/3 plus c. Again, we can check this answer. When I check this, I get 1/2 of 6, which is 3. X to the negative 1/2 plus, bring that out front. I get 5, x to the 2/3, and then I take the derivative of the c, which is just 0. More antiderivatives. So on this one, we don't know special rules yet for antiderivatives, which we will learn them. So what we need to do is go ahead and we're going to FOIL this out first. So I've got x squared plus 6x plus 9. So we're going to multiply the polynomial x plus 3 times x plus 3. And then we're going to find the antiderivative of this. So we're going to raise it by 1 and put it over that power, plus raise it by 1 and put it over that new power, plus 9x plus c. We can simplify this a bit. The antiderivative is 1/3 x cubed plus 3x squared plus 9x plus c. I'm not going to do the check on that one. The next one, again, we don't know any special rules, so we want to go ahead and simplify this first. So x divided by x cubed is x to the negative second minus 5 divided by x cubed would be 5x to the negative third. So when I take the antiderivative of this, I get x to the negative first over negative 1. Remember, we're raising it by 1. So 5x to the raise it by 1 power gives me negative 2 over negative 2 plus c. So the antiderivative is negative 1 over x when I'm cleaning this up. We have a negative negative, so it actually makes it positive 5/2. And the x squared goes on the bottom plus c. And we're done. Again, I'm not going to do a check on that one either. But plenty more examples here. What this looks like is an entirely different type of problem, but it's the exact same thing. It's just an indefinite integral. And really, look at the difference. This one, they're giving me an equation, and this one, it's not an equation form. This is an integration sign. So, a new symbol for us. What it means is that we're going to use the rules of antiderivatives. So when we find the antiderivative of this, the integral of this, we're just using the same rules. So we'll put an x on here and put plus c. Now, if you want to do the check, which you can do every time, take the derivative of this, which would give you 5, and the derivative of the c is 0. So we know we have the correct answer. So this one said take the integral with respect to x. This one, on the other hand, says take the integral with respect to y. So instead of putting an x on our answer because it said with respect to x, we're going to take and put a y with this because it's with respect to y. So the answer on this one would be 5y plus c. Continuing on here, take the integral of 5x squared. We take the 5, rewrite the x, raise it by 1, put it over that new power, plus c. We could clean this up a little bit by putting 5/3 x to the third plus c. But this is as far as we can take it. Again, you can do a check every time. Bring the 3 out front, multiply those together, get 5, lower it by 1 gives you x squared. Next problems, I would recommend rewriting the integral in this problem so that you can see the negative 2. Make it easier for people to take the integral of it. So we will write negative 7 x to the negative 1, because that's raising it by 1, putting it over that power, plus c. I'll clean this up just a bit. So I get 7. This goes on the bottom, 7 over x plus c. And the next one, all these are with respect to x, so that's why I keep putting an x on them. We'll just go ahead and start taking the integral. We get 3x to the second over 2 plus x plus c. You can stop. Last example on this slide, we'll rewrite this first of all. And when we take the integral of it, we get 2/3 x to the 1/2. X to the 3/2, raise it by 1, put it over that power, plus c. We'll clean this up. 2/3 divided by 3/2 really is 4/9. X to the 3/2 plus c. Maybe you don't feel comfortable with that, you can check it. 3/2 times 4/9 is 12/18, which does reduce to 2/3. All I need to talk about left is the trig integrals, and that will be the end of today's topic. Last part of today is the trig integrals, and so these are things you're going to have to memorize just like you did with the derivatives. Now, if you've already memorized the derivatives, it does make the integrals that much easier, because if you take the derivative of sine, you get cosine. So if you're taking the integral of cosine, of course it's sine of x plus c. If you take the derivative of cosine x, you actually get negative sine. But notice how there's a negative out here, so a negative sign would make a positive sign. So each of these you can check by knowing your derivatives of integrals. Notice one of the things I remember when I'm thinking about my trig integrals is that all the anytime I get a cosine, cotangent, cosecant answer, there's a negative out front. If I'm just getting sine, tangent, secant, so it's not one of the cosines, cotangent, cosecants, I know that it's a positive answer. That will help you when you're taking the integrals. So we're going to go ahead and take the integrals of each of these. So if I integrate this right here, one of the rules with a constant out front is you can just rewrite that part. The integral of sine x is cosine. It's actually a negative cosine plus c. Remember I said anytime you wrote the cosines or the cotangent or the cosecants, you'd put a negative out front. You can check this, so if you check it and you take the derivative of this, you would get, and this is just a quick check, take the derivative of this, you'd get negative 2 times negative sine x, and then the derivative of c would just be 0. Well, negative 2 times negative sine gets you back to a positive, so you can feel confident in your answer. The next one, the integral of 5 cosine x, is you write your 5, take the integral of cosine, which is sine, and then put c on the end. Last example for today, the integral of x squared is x to the third over 3, raise it by 1, put it over the same power, plus the integral of sine is negative cosine x, and we'll put plus c on the end.